Hi there. Today we're going to go over Chapter 8.2, Modeling and Solving Linear Systems. I'm planning to separate this into two different lectures, so this would be the first part of it. We'll go over first two examples together. So example 1. 4 students, Anne, Bethany, Clyde, and Daniel, are raising money in a school fundraiser. Their current total and donation rates are shown in the following table. So I will label these names as A for Anne, B for Bethany, Clyde for C, and D for Daniel. And they want us to write equations for each student and graph each line on the same grid. So first thing we need to do is note that the current total is indicating where we're starting at, where all these people start at, and then donation rate is how much it goes up by per week. So I'm going to denote total amount fundraised will be T. And number of weeks is denoted as N. All right, so we can say that the total amount would equal to donation rates. So the rate times number of weeks. And then we add where we're starting at. So we started at the current total here, current total. All right, so I wrote this in words so I can kind of understand where this equation is coming from. So using this, we can say that N would, for N, total equals to, rate is $20 a week times number of week plus current total is 240. All right, and then for Bethany, total equals, Bethany's rate is 30, 30 times N plus current total was 120. And then Clyde, total equals 30 times N plus 60. And lastly, Daniel, D, total equals 60 times N plus 0. Now that we have equations for the 4 students, let's actually set up our axes before we graph it. So in this case, in our equation, so the independent variable will be n. So n goes on the x-axis, and t goes on the y-axis. All right, so we are going to go up for n by 1. So 1, 2, 3, all the way up to 8. And then for t, we're going to go up by 60. And you are free to choose any other values as long as it's consistent. But I chose this because when I graph it, it's quite exact. It's easy to find the intersection this way. All right, so now that we have set it up, let's take a look. So I'm going to color code this. So for n is blue. So for n, we're starting at the y-intercept is at 240. So we're going to start at 240. And notice that it's going up by 20 per n, but my grid doesn't go up by 20. So it goes up by 60. So you need 3 20s to have 60. So I'm just going to go to when n equals 3, right here, then you add another increment. So our next point would be right here. Okay, so hold on, right here. So this is to minimize, finding coordinates. So this way I can actually find a nice coordinate that is on that intersection here. So I'm going to connect that point. I think that's pretty good. Yeah. And just label it right there. So that's for N. For Bethany, we're starting at 120. And again, this time the rate is 30 per week. So you need 2 30s to have 60. So I'm going to go to N equal to 2 and then go up by 1 whole increment. And then we're going to connect the points. This is close enough. And that's for Bethany, and let's do Clyde. So we're starting at 60 now. It goes up by 30. Same thing, you need 2 30s to make 60. So right here. Connect those points. And then lastly, Daniel, we're starting at 0. And we're going up by 60. So this time it's easy to plot. We can just go 1 up, 1 right, 1 up, 1 right. Oops, like that. All right, so now we have graphed all 4 equations. Part B. How many weeks will it take for Daniel to catch up to Bethany? So Daniel is the green one, and Bethany is the red line one. All right, so let's take a look. So in order for us to determine how many weeks it takes, we need to find the intersection. So when does this happen? So Daniel's green and Bethany's red. This is the intersection. And this happens when n equals 4 and t equals 240. So Bethany and Daniel, they intersect at coordinate 4 and 240. And so we can conclude that it takes 4 weeks for Daniel to catch up to Bethany. Same idea for part C. So will Daniel ever raise more money than Anne? So Daniel's another green one. Daniel, Anne is blue. So let's take a look. This time, when does this happen? Part C. Okay, so my graph isn't clear here. It should be this way. There we go. All right, so now we can see that this is an intersection. So this happens when n equals 6 and t equals 360. So we can say that A and D intersect at coordinates 6 and 360. Okay, so will Daniel ever raise more money than Anne? Yes, because after the week 6, Daniel's above here, above Anne. So he will always earn more and more over the week compared to Anne. Okay, so we have to write this in Word. So yes, Daniel will raise more than Anne after 6 weeks. So this is for example 1. Moving on to example 2. The highway distance from Edmonton to Edson is 200 kilometers. Heidi leaves Edmonton at noon on her bike and averages 25 kilometers per hour. Cameron leaves Edson by car at exactly the same time and drives at 100 kilometers per hour. They want us to state the two equations, and part A asks us how long would it take for Heidi and Cameron to pass on the highway. So before we start our question, let's set up a diagram that would help us to understand what kind of situation we're given. Okay, so there's Edmonton and Edson. All right, so from here to here, the distance is 200 kilometers. Heidi is from Edmonton traveling to Edson at speed of 25 kilometers per hour, whereas Cameron leaves Edson to Edmonton at a speed of 100 kilometers per hour. So we're looking for some point here or here that they intersect when they meet at a highway. Okay, so let's set our equation here. All right, so first equation is that we'll first need to use everything we know. So we were given speed of them traveling, and notice that speed is distance over time. Okay, so equation 1 will be for Heidi and equation 2 will be for Cameron. And they both have to have a distance and time in it because we only know speed. Okay, all right, so here for Heidi, we know that the distance from Edmonton must equal to her speed times time. Because if we reorganize this equation here, or formula here, distance equals speed times time. Okay, so all we're doing is rewriting in words, and this we can denote as D equals speed for Heidi was 25 kilometers per hour times time for T. Okay, so distance equals 25 kilometers per hour times time. So we're done with equation 1. Let's take a look at equation 2. Now this time we want to write an equation for Cameron. So for same setup for Cameron, we have the distance from Edmonton, and this equals to speed times time. So notice that this is distance from Edmonton. Okay, so this time we do have to take into account that we are given the total distance from Edmonton to Edson is 200 kilometers. So we do have to use 200 kilometers at some point, and this is the time. So the distance from Edmonton for Cameron is 200 minus D. Okay, so distance cannot be above 200, so it's important to note that here. And then speed is 100 kilometers per hour times time. Let's rewrite this into the y equals mx plus b form. So d equals negative 100 t plus 200. So now that we have two equations, we can graph them. So let's set up our grid. So time is always an independent variable, so we have to set it as x-axis and d for y-axis. And I will set the increments for time as 1 hour, 2, and 3, all the way up. And for distance, we'll go up by 25. And I need to make sure we have 200 because that's the maximum distance we can have. Right, so we'll start with our equation 1. I'm going to use blue pen for this. We're starting at 0. At time equal to 0, we're just plugging it into time equals 0 here to find d. Okay, so we start at 0, and it goes up by 25 every hour. So up 25, and keep going just like this, all the way up. So it's safe to say that Heidi takes 8 hours on her bike to get to Edson. So we'll connect the points. All right, so this time we don't want arrows because it has to end at some point, and this is going to be at 200. D equals 200, that's where it ends. So this is equation 1. And I'll use red for equation 2. So this time we're starting in the y-intercept is at 200. So we're starting at 200, we're going down by 100. So starting at 200 at time equals 0 for equation 2 goes down by 100 each hour. So here and then here. Okay, so we're going to connect the points again. And again, do not write the arrows here. No need. It ends somewhere. All right. Okay, so we can see that there's an intersection here. Right here. The only problem we have is that we don't exactly know what that coordinate is. Okay, so for part A, when we're answering, we do need to be very careful, saying that from the graph, it takes approximately some certain hours. So let's approximate it. So we're looking for time, so I'm just looking for t here. So this is a little more than 1.5, so we'll stick to 1.6 hours. So we say from the graph, they are approximately actually it takes approximately 1.6 hours to pass on highway. All right, so for part B, this time we're looking for how far away from Edmonton are Heidi and Cameron when they pass. So this time we're looking for distance. So let's take a look at this intersection here. So when you draw a straight line here, that value looks somewhere in 40s. So let's stick to 40. So from the graph, they are approximately 40 kilometer away from Edmonton. Edmonton when they pass. And this time we want to complete the algebraic solutions here. So as in we're going to verify by solving algebraically. For part A, we'll just list the equations for the Heidi and Cameron. So we have d equals 25t, and equation 2 is d equals 200 minus 100t. So when we're solving it algebraically, we do need to make these two equations equal each other. So we're going to let d equals d. Okay, so what I mean by that is that this d here from the first equation goes right here, and the second d from the equation 2 goes right here. So essentially we're substituting. So 25t equals 200 minus 100t. And then you're going to isolate t. First, you have to collect the like terms. Okay, so let's add 100t to both sides so we can combine the t's together. So we're left with 125t, and on the right hand side we have 200 left. And we're going to divide the entire equation by 125. So we're left with t by itself on the left hand side, and we're left with 8 over 5, which is exactly 1.6 hours. For part B, since we know that t equals 1.6 when we pass, so t equals 1.6, we just need to sub it into the equation to solve for the distance. So let's pick equation 1 because it's a lot simpler than equation 2. So we have d equals 25t, and we're going to sub in right here. So we have d equals 25 times 1.6, and this turns out to be 40. So distance away from Edmonton is 40 kilometers. So we have verified that 1.6 and 40 is a correct solution set. So this is it for first part of 8.2. I'll see you guys in the next video.